This is going to be an exciting talk, and for many of you, probably on a new topic that you haven't explored in depth before. So thank you for being here. A little bit about Ryan, and then I'll let him tell you his story, his journey, of how he came to be who he is today. Ryan serves as a general manager for responsive retail in the Internet of Things group at Intel. He works with IoT and cloud ecosystems. If you don't know what that is, you will learn that, hopefully. He is a proven leader and a problem solver, and really a creative problem solver. And what he does will hopefully fascinate all of you. And we are video recording this talk, so we can also make it available online for students who couldn't be here. He has been a change agent throughout his long career at Intel. And that itself is a testimony, right? It's very rare for somebody to be at a single company for as long as he has. And he obviously thrives and enjoys what he does. That is something you will have to find for yourself when you go into the world as engineers. He was highlighted in the Intel Rockstar advertising campaign for his transformative work, helping retailers merge the online and in-store experience, benefiting customers such as Macy's, Procter & Gamble, Walgreens, Best Buy, Kraft, and Adidas. His worldwide teams have been featured in many prominent publications. And here's Ryan.
Great. Thanks so much. Well, thanks for coming tonight. I really appreciate all of you being here. You know, when I was thinking about this, I thought, okay, years and years ago when I did this, what would I want to hear about? What would be interesting? And the number one thing was, you know what, let's try to make it interactive because I want to make sure I'm giving you what you want. Does that work for everyone? So just blurt out the question. I'll try to repeat it for the cameras here so that it shows up on the recording, but I think it'll be more fun that way. So what I wanted to do is walk through my story a little bit, kind of the origins, the journey, including ASU, and then walk into what I do today and some of the things I've done. If any of these are more particularly interesting or less particularly interesting, love to hear it, and we'll just kind of go as you want. Make sense? Okay, so my childhood was actually a lot different than most, and I'll walk through it. So you can see up here, was born in Montana in a place called Billings. Billings is the biggest city in the state and sports 100,000 people. Okay, and so you can see Billings up there in the upper left. There's these wonderful rims. It's kind of a little freaky. You fly in and then all of a sudden you just land because you land on top of them. But that's Billings, very much on the breaks between the prairies and the mountains. Down below, the Beartooth Mountains, that's the Bear's Tooth right there, hence they're named after, was in the background for us. And in 5th grade, our parents got divorced. And we moved to the small town that my parents had gone to school in, and my grandparents had gone to school, and so on and so forth. And it was called Joliet, and they have a local artist here named Chuck Ringer who loves to make crazy creations. And if you drive down the road, there's two things you'll notice. One are these crazy creations outside. And the other thing you'll notice, if you're going too fast, is a speed trap. So this town is 100% funded on speeding tickets. So if you ever go to Joliet, Montana, absolutely do not speed. It's one place where you should know. And every small town in Montana kind of has the same gig. So just be aware of that. Just saying, it's not cheap. So anyway, that's where I grew up. Little tiny town, moved there, and it was so small that I played sports, played in the band, I did all the honor society stuff. Anything you could possibly imagine, you did because there weren't enough people. And I'd like people to try to guess how many people I had in my graduating class. Yep. 150. 45. 15. Oh. Okay. 5. Wow, this is like the Price is Right here. All right. So I will tell you, I barely graduated in the top 10% of my class, but I was valedictorian. So I had 11 people. So between the 5 and the 15, 11, can you imagine? Yeah, so it's literally that small. Like, who couldn't graduate first, right? I mean, so that's what I grew up with. A very small town, very poor town actually. You know, if you had a car or something like that, you were like the rich kid. Very agricultural, and so most people went on to run their parents' farm or whatever it may be. That was kind of what the background was. So growing up, when I was 5 years old, I have no idea why I did this because I had forgotten it, and I'll talk about that. I had 4 things I wanted to accomplish at 5 years old. First, I wanted to be an electrical engineer. My uncle was an electrical engineer. I had no idea what it was, no clue, but I wanted to be one. I wanted to get an MBA, and I knew even less about that because I didn't know anyone. It must have been like in the newspapers or whatever was cool for media at that time. So MBA sounds great because they make a lot of money, which got down to this one. And for some reason, I had to own a Porsche. Not even sure I knew what a Porsche was at the time either, but those were my 4 goals, and I'll give you my status report at the end so far. All right, so I was 5 years old, and if you think about it, when we're all kids, we have these aspirations that are just unabated. And so one of my messages to you is make sure you're not self-limiting on what those things you can achieve and accomplish are, because I think it's so important. As we get older, the constraints of society and everything come on us. And as 5 years old, I mean, just think like a 5-year-old. It's amazing what kind of progress you can make. So these are my 4. Status report at the end. I'm an Intel guy. We're all about our deliverables and achievements. So in this high school, I was a junior, and I was thinking, hey, what am I going to do after this? And I could go to college and play football. That sounded kind of fun. I could go to college. That didn't sound very fun because it sounded like a lot of work. Or I could do what everyone else did who had high aspirations in this small town. I could go work for this refinery here in Laurel, Montana. Or I could go work for the railroad fixing either the locomotives or the actual rail lines. And by the way, rail lines at 40 below does not sound great, but for some reason that did sound great to me at the time. And you could make $15 an hour, and you have to, this is a long time ago, so you have to adjust it. Let's call it like 30 bucks an hour today. That's pretty good money. But that was kind of like it. That's the best you could possibly think about doing in that kind of a space. And so I was kind of debating, am I a railroad guy, am I a refinery guy? I don't know. And then I spent my summers working in this small little town that I grew up in. And it was so small, 11 students in my class, okay, that's, you gotta put it in the right size. We did everything, okay? Right there, that is what they call a sludge auger. And it takes the local stuff from all your sewers and it chops it up into smaller and finer things. And it turns out these sludge choppers break down all the time. And someone's gotta go in there and gotta go fix them and get them working again. Here, hey, if a sewer line or a water line broke, hey, you're on it. People need water, people need sewer. So we'd be digging it and cave-ins and just nasty, nasty work. And then probably the worst, even though the sewer sounds even worse, was garbage trucks. Not like they are today where it's all automated and they have that fancy arm that picks them up. Oh no, we had tin cans you would pick up, lift and dump in the back, and then you get on the back of that with the step and it would blow in your face as you're riding down the road. And by the way, you can tell some amazing things about how people live. Just saying, from their garbage, it's totally true. That entire experience alone made me say, you know what, I'm going to college. That's what did it for me. It wasn't the football scholarship possibilities or any of that. Nope, it was that job right there. And so from there, I actually went to undergraduate school at Montana State University. And I started as a physics major. And my first year and a half was a lot of fun. It was a learning experience in the social setting. It was not the learning experience I probably should have had. And I lost my scholarship. And when you lose your scholarship, you start to think about, wow, I got to pay for this. Like, this is kind of a big deal. And I decided, I stay in physics. I have to go to school to get a postdoc. That's a lot of debt. You know what? I'm going to go be an engineer. And so I switched to engineering and did industrial engineering for them. They called it industrial management at the time. I loved it. It was the union of business and engineering. And I thought, you know, that's really for me. And that's kind of been my career. I'll walk through in a little bit. So I got my undergraduate in industrial engineering, worked for Intel in New Mexico a couple years, and then moved out here. And when I got here, I said, you know, I'm just not done. I'd like to learn more, gain some new skills. I really feel like the business side is where I could add some value too. And this blending of engineering and business was just very intriguing to me. And so I went to ASU, got my MBA at night in the high-tech program, which doesn't exist anymore. And I will tell you this about the high-tech program. It's all engineers and scientists. It's like curve wrecker class. I don't know what I was thinking. But it was great because we could use calculus and all these sort of things and learn from that perspective, and I really enjoyed that. Got my MBA, and then said, you know what? I think it's time to go get a PhD. So I started my PhD here at ASU. And it turns out when you're working full-time, you have this balance, like, what are the trade-offs going to be of getting a PhD versus, you know, trying to do my job well? Intel's a very competitive place. And so about 2 years into it, I unfortunately let ASU down and decided to just focus full-time on my career. But I think I took all those learnings with me and applied them there. And for me, my background is highly in statistical analysis, designed experiments, simulations, those kind of things. That's my background, and I did that at Intel. We were doing genetic algorithms in 1996. I mean, it was some of the crazy stuff to optimize. And a fab today, which is where we make all the chips, anyone know how much that costs? $1? Anyone? 1 trillion? Yeah, it is. It's $9 billion. $9 billion. So if you make a mistake, running my models, doing all this analysis, you make a mistake, we have 6 of them. That's a really big mistake. And so we have very complex models, still do to this day, very deep understanding of the full supply chain, fascinating field, lots of different kind of applications on how to optimize that big global problem. But that's what I did for my first few years. And in 2000, I actually switched over to the business unit to work on the product side. Now, interestingly enough, when you have a $9 billion investment, it's super easy to find how to save money. You're like, $9 billion, I mean, how can you not take something off that number? Coming to the business unit size, starting a brand new business, way harder. And so we'll talk about that too. Questions here yet? Doing okay? Okay, so when I graduated, like I said, I came to Intel and I had kind of a couple rules. I said, first thing, growing up in Montana, it was really, really cold, and we had some of our worst weather when I was in college. So I drew a line at Denver, and I refused to take an interview north of there. So I had co-opted 3M and stuff, and they're like, oh, come back. And I'm like, nope, not even gonna talk to you. And they're, what? Too cold, not gonna do it. So I'll only take interviews south. That was one. And then I wanted someplace that really was into creativity. And when I started Intel, I saw this quote and I said, this is exactly for me. I've been with the company 21 and a half years now. And this spirit of innovation I've always loved and just been really intriguing to me, because how often are we encumbered by history? You know, why do you do something? Well, I've always done it this way. I don't know. Well, why not go off and do something wonderful? I mean, who could get upset about that, right? And go off and change the world and do great things. And I'll walk through some of the examples, but I will bet you the projects that I have done, every single one of you has interacted with. And I'll bet you maybe 10 of them. So what I love about Intel is we have the scale that impacts billions. And that's, sometimes big companies can get a little frustrating, but impacting billions and having that kind of an impact on society is just great. I love it. I think it's a lot of fun. I get to work with some of the smartest people, and it's really amazing. So, one time I was asked, hey, can you tell us about your career? I think 21 years is a long time, and you start writing this stuff down, and you get this like 2-point font, and then absolutely no one on the planet cares, right? Because who does? So I thought, you know, it might be interesting to organize it a little differently. What if I talked about it in epics, which when you get old enough to have epics, it's not a good thing, just so you know. So that's kind of across the top. And then I thought, you know, what skills were needed? Because a lot of times we don't talk about this, especially in undergrad. Like, well, what did you actually have to know? What did you have to do? And then, you know, kind of the impact on the business overall. So I'm going to walk through this real quick. If it's interesting, we can go as deep as you want on any job you want, or we can just fly through it. So basically, I started in manufacturing, and this was always important to me. I actually got a manufacturing engineering option out of my degree because I just love making stuff. And so for me, it was like, wonder how that works, how it puts together. Maybe it was too much time on the sewer pond, I don't know. But I always loved making stuff. And so I started in the industrial engineering group, even though I was a manufacturing process type engineer. And I thought, okay, well, this is interesting. Solved some really interesting problems there, and then moved to Fab 19. If you look at Intel's history, you will not find Fab 19. That's why it's colored red. You'd come up with this really innovative way of reusing our equipment that was in all the factories. And it turns out we were competing against Israel at Fab 18. And they said, hey, I need you to try to come up with the plan to beat Israel. And by the way, their taxes are such that they build it for free. Can you beat it? Now, this is one thing you should never ever say when you're out there as an engineer. You never say no. That is never an acceptable answer, ever. You can say, yeah, let me take a look at this. It could be $1 trillion. It could be, you know, billions of years. It could be, you know, meteor comes from the sky. It doesn't matter what the answer is, but there's always an answer to the problem, and that's how you have to think about it. And so what I did is, from my other experience, I spent all this time on the floor with the techs, because by the way, the people doing the work really know their stuff, and if you just ask them what to do and do it, you'll become a hero like overnight. So from doing that, I had helped them find extra equipment. You know, there's obviously the add more equipment, get more throughput, they're happier. And I said, wait, I could actually build an entire fab out of all this stuff we have laying around. And I did. And they said, I love it, Ryan, that's a really creative option, but we could do that in Israel too. And so they went and put all that equipment in Israel for free, got the tax subsidies on top of it, and I was like, I don't have a job. This is kind of interesting. So I moved to another group here in Arizona, which was called FSM Capital. And these are the things you'll learn. So we had all these different factories all around the world. And what they always wanted to do is get the next generation technology, because if you had that, that ensured the jobs for your entire factory. Well, they'd game with each other. They'd say, oh, yeah, I have lots of that. That only costs this much, because they take their previous generation stuff and use it forward. Well, then someone had to backfill it with new stuff. So all these games going on. And so I had a head of manufacturing then, Bob Baker, and he came and he took the top person out of every fab in the modeling space. And he said, I'm tired of this. I don't want games. And so, you know, I was feeling pretty good. Like, top guy out of Arizona, it's our lead fab. This is great. And he told me something that you all should remember, because this is really important. He said, I brought you here because we have this big problem, but I want to tell you something. I formed a centralized group because I had no choice, but I hate central groups. And he said, you know why? Because they always lose touch with reality. And it turns out that is very true. Every time I've seen central groups, you bring the right experts in, but over time they lose touch with reality and they forget what their mission is. They get a little ivory tower-ish on you and that. And so I always thought that was a great lesson. It stuck with me my entire life. Every time that someone asked me to do a central group, I'm like, I need a charter, a mission, as something, because I'm not going there. So I learned a lot about engineering. Also learned a lot about software. Turns out they didn't have anyone to write the software for all the simulations, all the models and everything. So I was the guy that built it. Started managing at that point, learning about it. Here, I wanted to highlight one thing, which is Anthropology 101. Anyone taking anthropology? I had to take it as my rubric. Don't know why, but I took it. And it was helpful for two things. One is parties. Great conversation about what the tribe did in someplace. Really great facts. And the other one was this thing. And I never thought about it this before. I'm just too logical as an engineer, I think. Every single thing that people do is a trade. So we are doing an exchange. You're telling me your ideas and I'm validating that idea with my response. I'm giving you something physical. Whatever it is, it's always a trade. And so if you can apply this into your regular life today, if someone comes to you and says, can I help you? Yeah, sure. I've just traded you. And what have I traded? Now there's an expectation you're going to give something back. It's how society works, right? It's what makes it work. But what I found was if I could go in for these techs, their workstations were terrible because they couldn't run the whip right or whatever. It was really simple stuff. I would change it. They would come to me with these just amazing ideas, and I still use it to this day. Every time I walk to a customer, I'm like, hey, I'll tell you what. I know you're not willing to give me anything yet, but here you go. I'm going to give you this for free. It is amazing what that little tool will do. It's just in our nature to trade back, right? That's what we do. And so I learned that, and I think that one always stuck with me. I then moved to the product side after I got my MBA. Spent about 8 years there. I must have bad luck on the first of everything because the PME is a product marketing engineer. It's a fusion of business and engineering, so translating engineering requirements from the customer into product and then being able to relate what the value of that product back is. And I was in the job about 6 months and product got canceled. So that's never fun. And so I learned another valuable lesson here. You can see 2 reds showing up. It actually doesn't matter what job you have. It matters what skills you have and how you approach change. It's really true. And so for me, I said, okay, cool. What do you want me to do next? Well, we need you to wind this down. Great, happy to do that. What else do you want me to do? And that attitude has served me very well. You can see all these different boxes over time because they know I'm one of 2 things. I'm a problem solver or I'm a startup, make it happen kind of guy on some random idea. And that kind of approach has always been great. Started up storage, so all the EMC and everyone else before anyone knew about them ran that, got them going. Started up a whole bunch of verticals from healthcare, military. Funny one was casino gaming, all the slot machines. Actually had 60 minutes trying to think I was trying to make people gamble more, which was an interesting interview. Never want those. Turns out they are about gotcha. I didn't realize at the time. But what we did in that product was pretty cool. So we had actually integrated a camera, and this a lot of years ago, integrated a camera, and we said, you know what would be cool if we could detect someone's face, and they've opted into something like Gamblers Anonymous, we could lock them out of the machine. And if we did that, isn't that a good thing? Because they have a problem, they need help fixing it, and we solved the problem, right? That's what engineers do. And so that was actually the thing that was kind of the gotcha, and it was a little frustrating because we were really trying to do a societal help. But overall, those kind of technologies now are being used in lots of different places, and that's pretty cool. E dash dash dash. Anyone ever seen that one? Okay, that's Ericsson. Probably still no one knows that. Ericsson makes almost all the towers, probably half now with Huawei, of the towers that make your cell phone work. So you've never heard of them, but your cell phone would not work without them. They do all the telecommunications on that. So just remember Ericsson. They're a good company. They actually started, when I was Nokia, they were another one around doing it too, making rubber tires or rubber boots or something. It's pretty amazing how they transform, but that's in Sweden. And I did an international assignment in Sweden for a while. If you ever get the chance, do it. You would think Sweden, you're thinking, oh, it's a lot like the US. Nothing like it culturally. And it was a great, yep. Was Sweden. Well, so you have to remember, I'm from Montana, so it didn't seem that bad. It was a little dark for me. We had 4 hours of daylight. Yeah. Yeah. So Sony Ericsson, it's a great one. Ericsson made all the base stations, and they kind of got into phones just to push more phones on so they could sell their networking equipment. But then it became a huge business for them. The cell phone industry, this is pre-iPhone, had gotten pretty stagnant. And Sony was a great consumer electronics company that had kind of that user experience. They had a big gaming platform. PlayStation was kind of coming out then, all that. And so they did a joint venture on that to go build that. So yeah, exactly. Oh yeah, they're told James Bond cool. And if you look up that phone now, you're like, wow, I had it. I was feeling great. My brother actually killed it because he dumped a beer on it, but that's a whole different story. Yeah, they were great, and it was fun working on that stuff. And you know, sales is a completely different world if you ever get a chance to try it. I'm too much of an engineer. I'm kind of more into the logic and the facts of stuff than the trust me, it's going to be great. So I said, that's not for me. And I came back and ran our channel business, and then came to retail and ran that, medical and energy. Great businesses, selling our chips into point of sale. We actually worked on MRI machines, so we were able, with increased compute processing, to reduce the dose that you were getting so people get less radiation. So just tons of fun things. Cruise missiles down in Tucson. You think, well, why'd you work on a cruise missile? Well, it turns out you have like something like 30 microseconds to boot it. No one had ever done that with a computer because you turn it on and you wait, right? That's what Windows does for you. So like, can you boot it in 30 microseconds? We could try. And sure enough, we got it to do it. So it's kind of some of these really fun, interesting, you know, small things in there. My favorite one, I had a customer say, hey, I need help with my chicken fryers. I don't know anything about chicken fryers. Anyone know anything about chicken fryers? So what's the problem? What are you trying to solve? And they said, oh, well, actually, we're all franchisees, so someone else owns the store, but we provide them product and brand and equipment and all this sort of stuff. And it turns out if you're paying your own money for the chicken, you would rather have it sell out, and so you'll leave it on the shelf longer. But if you're the brand, you'd rather have it taste good, right? And so that's what you're trying to do. And so what we're really trying to do is balance that. So we actually went and took their cash registers and synchronized them with the chicken fryers and ran an optimization algorithm with them to go do that. And so, you know, some of these customer journeys, you just never know where they're going to take you, but there's always an engineering problem in it at the end. Okay, next one was HEMS. This actually won top 25 breakthroughs to change your life. How many people have a HEMS? Yeah, it's red, isn't it? So this is one where you can get the product right, you can get the pricing right, everything right, and it still fails. And so we were too early, and this was the early instantiation, and it led to what I'm doing now of IoT. So we said, you know, in your home would be cool. You have a PC to help manage you. Do you have something to help manage your home? No. Wouldn't it be cool if you walked into the room, the lights came on, the temperature went down, you know, and it just adapted to you. The TV came on if that was your thing or whatever, right? And so we started building all this logic in, came up with this just great interface. We actually beat the iPhone to Gorilla Glass. We beat them in several of the things that they announced. That was right at the time iPhone was coming out. So we were just totally proud of it, won all these awards, and then, yeah, just turns out market wasn't ready, trying to get sensors from billions of different vendors to work together, not be proprietary. It's a huge political problem as much as anything. And so the project failed. And at this point, you know, I'm managing pretty big teams, so you're the captain, you're going down with the ship, so you're trying to find homes for everyone before you get to jump off. And so I did that, and they said, hey, there's this thing called Internet of Things. Could you go build a strategy for it? And fortunately, now we have a whole group around this, and I'm going to show you what that looks like in a minute. I was really excited about that, was doing great, and Diane Bryant, who ran our data center business, said, you need to come up here to the data center side. So I asked around, anyone tell Diane no? Nope. I guess I'm moving. So I moved to Oregon for 4 years and did a lot of cool things. So people saw the Altair acquisition, probably we did years ago, helped drive that. And then I ran 2 breakthrough kind of groups, and it's red for me because I didn't get to finish them. One was on 3D Crosspoint. I don't know if anyone's heard of that technology. So think about DRAM memory meets your SSD, and the best of both are in one product. So now all of a sudden your memory in your server, is what we were in server world for cloud, can persist, and it's flat. And it's, let's call it hundreds of nanoseconds, not, you know, hundreds of microseconds. Think about that latency difference, what it can do for your computing. So I was like nerding out. I'm like, yeah, this is the best thing ever. How do I go build this product? We're going to put it into DIMM. It'll fit in a standard server. This is great. Product's been delayed a little bit. It's out in the news and public, but super cool technology. Once it's ready for prime time, it's going to change computing completely. Yeah. I can't comment on future events. But what I will, I'll answer a different question because you can go buy it's called Optane in an SSD. You can buy it today for your gaming PC. And so that's out there, and it's just an SSD that really screams. The bus is the actual limiter in the speed.
So is it at all related to NVMe?
Yeah, so NVMe, good. I'm glad someone actually knows what that is. So there's PCIe, which was our interconnect, or PCI used to be, the interconnect we had forever for standard stuff to drop in. Much higher bandwidth than a traditional serial ATA connector that you would have for a hard drive. Sometimes lower latency. That was kind of a little bit all over the place, but a lot more bandwidth. And so we intentionally said if we could use the PCIe lanes and change the protocol that was running across them, we could get our learning starting point and get people to start programming different. Because this is a completely different paradigm on how you program. What if you didn't ever have to wait for a disk? And I think one of our engineers had it. He said, we were in Portland at the time, so you got to put yourself in Portland. And he said, hey, you know what? If I want to take a trip to memory, I'm going to walk 2 blocks and come back. If I want to take a trip to my hard drive, I get on a bicycle, I'm going to ride to Florida, and I'm going to come back. And so that's the difference in it. So we said PCIe and NVMe off of that was a great way to get, maybe you only go to Oklahoma or something like that, right? But the ultimate is I go the 2 blocks. If I could go the 2 blocks where we not even go anywhere, that would really break through and change computing. That's exactly. And I think this is probably another good lesson. I have lots of engineers that try to 100% the problem the first time. It's usually a great way to fail. If you say, okay, how do I aspire to be that so I can keep the innovation and the creativity going towards that? But how do I back calculate the steps that would get me there? Now I can get product to market, I can generate revenue, I generate revenue, they'll invest in me for the second generation. And so NVMe was a big part of that. And yeah, pretty fun thing. And what people don't know is every single Intel server, we worked with all the different vendors, has that enabled, which is another thing because we had the processor and the chipset. We could do that, and so we could drive the adoption much faster. Yeah, the other one I was working on, so think this one was how you can stack atoms to make a switch, right? Which was kind of what the 3D Crosspoint was. And the other one was, hey, you know what? What's the next generation data center look like? Has anyone seen the pictures of like Facebook or Google data center? AWS? Yeah, it's like football field in size. It's just massive. And it's full of servers. And so we said, hey, you know what would be cool? There's a lot of wasted resources in a football size kind of thing. What if I could say, you know what? You only need a little bit of memory, a lot of storage, some networking, and some compute, and I could compose that dynamically and autonomously. Wouldn't that be cool? Wouldn't it free up a whole bunch of latent assets and you could be a lot more efficient? And you could start to solve problems that you couldn't before that only high performance computing workloads had done. Yeah. Yeah, so what it does is there's, again, we'll go in steps. There's I pre-sized what that kind of application takes, and so I'm going to allocate that dynamically. Eventually, it's going to learn what you need and reallocate on that. So that's what we're trying to do from that perspective. And this is across millions and millions of CPUs that we're doing this autonomously. Really cool stuff. Still underway, still under development and deployment. And then the final one, yeah.
Going to the saying no to good ideas part, sorry if I'm jumping around.
Love it.
What are some of those that you've said no to?
Yeah. Yeah, you know, it's interesting. So we actually had this really cool new way to shop, for example. It was very interactive, very free-flowing. A lot of people think, you know, they have that cash register. Well, what do they see that I can't see? Are they hiding the price for me? All that. So we actually went through the anthropology of it and came up with this great new concept. We'd be killing it. Had to say no to that. Now there's people making it in kiosks and things like it, hundreds of millions of dollars in it. Another one, I won't say which company, but one of your big cloud service provider types, we actually designed their first server. And then we decided, should we get in that business or should we just sell to them? We didn't get in the business. I think our multiple would look pretty healthy if we had a cloud service provider business right now. So there's some of these things, and part of it, that one was actually easy because it's not our core competency. It was hard to say I'm going to beat them in that. There are other ones where you're like, the expected return is just better on this one than that one, and I got to make a gut feel for it. And so like HEMS was one where ADT Pulse, you seen that? So that product was actually spawned out of our HEMS. And there's about 5 or 6 other ones around, billions of dollars being made in that space. Saying no to that one was really tough too. So it kind of comes and goes on them. There's some proprietary stuff we might do someday I don't want to talk about. But yeah, to me, my people come to me and they say, hey, I got a great idea. And I'm like, well, of course you do, because it's either a really big problem or a really great idea when it makes it to me. And so how do you foster that creativity and innovation in them? Okay, so I think that's the big one. The other thing that doesn't happen a lot, and I've actually worked a lot with undergraduate education on this, is collaboration and communication. I have seen people that not very technical absolutely excel in a technical field because they're great collaborators. They can bring people together, and they're great communicators, so they can make a very, very mundane, complex technology super obvious. And so I would say too, as you're thinking about that, and I know here they weave it into the courses, but when you're giving a presentation on something or you're working in a team, the whole point is to foster that collaboration, to foster that communication ability, and even tech writing. Tech writing is like gone by the wayside, and it is massively important. I see projects get derailed all the time because people can't write down what they actually meant. Anything else on that? That was kind of the 21 years at a page. Yeah.
Was Intel pretty good about moving people around, like if a project got canceled, not really laying anyone off?
Yeah, so we actually have a program. It's called redeployment. And so I love it because what we're always doing is evaluating what's the most likely to give the highest return. You know, it's a very high-risk business in tech. We're almost making our product obsolete every 18 months. That's our business model. And so when you're doing that, you're going to invest in a lot of things. A lot of them will pan out, some of them won't. But the people are still talented, and so we intentionally take those people and then reassign them to a higher value task, which is a terrific policy. It lets people have that creativity to go off and try something wonderful like we talked about without the fear of, there goes my job. Thought I saw one more. One more question? Yep.
Did you just confirm that you guys attempt to obsolete your products in 18 months?
Yeah, so if you look at what our business model is.
Well, I know it just hurts my wallet that and
You don't have to buy it.
well, the 8700K just came out today and didn't build a PC more than like 3 months ago, so it's like,
Now you need to. Yeah, but what that is a byproduct of Moore's Law. People know Moore's Law? All right. So one of them is I need more computing. It's not that one. What it was is one of our founders, Gordon Moore, he only thought this would last 10 years, and it's gone over 40, which is pretty impressive, said, you know what? About every 18 months, I can double the number of transistors on a piece of silicon. And if I can do that, I can either give it the same performance at half the cost, which is the cell phone model led us to, or I can give you twice the performance of what the server models led us to in the ultimate extremes of both. And so that's why it is. And if we do that, it then becomes economical for us to manufacture transistors and give them at a great price relative to highly custom, what the industry was before. So the business model is centered around obsoleting your product to keep that innovation and that Moore's Law going. Nothing nefarious there, just all about product density. Okay, next one. Anyone seen something like this before? Anyone ever seen the Missile Command back in the day? I'm really old, but if anyone's seen Missile Command, there you go. See, he read the archives. So this is my Missile Command slide, and it looks really, really cool. Missile Command was like, there's all these missiles coming down, and you have to shoot them down. And so that's really what I see the Internet of Things as, is Internet to the next extreme. And so I could have things we used to call these little specks here, like dust. Those are your sensors. So there's little sensors everywhere with some modest amount of compute usually doing stuff. That then talks to some kind of hub that's aggregating it and taking action at the edge. People ask, well, why not just put it in the cloud? Anyone know why you don't want to put everything in the cloud? It could be not safe. That's one, yep. I'll put that with the safe category, yeah, but I agree. Anyone? Yep. Yeah, there you go. You physically can't move that much data there. It's a physics problem. Photons only go so fast, at least as far as we figured out so far. And so you can only move so much, and if you want to move a lot of it, it's super expensive. Why would an AWS send a tractor trailer to pick up all your hard drives? Because it's not practical to move it across the web. It's just not. And so there's this cost and physics problem that's in there. The other thing is intermittency. And so I was on with a store, a major store that you would know, and they said, hey, we deployed this edge thing, and it was great, and we were using an orchestration software to manage it, and then we lost our internet connection, and the whole thing blew up. And it was like, well, yeah, of course it did. You know, it's got to be autonomous and be able to run on its own. And so that's what these nodes do here. And then those nodes talk to maybe more nodes that could aggregate theirs across the smart city or something like that, and eventually to the cloud. And so you get this very interesting, you know, trillions of sensors, billions of servers interacting together, learning together, and this is where all the machine learning stuff's coming out, the bigger umbrella of AI, all of that. And so what I'm trying to build, I'm going to start really small. I'm going to build this store right here. If I can build that store, I can then rinse and repeat it and go make an intelligent hospital and make an intelligent highway, an intelligent factory, all these kind of things. But I got to start somewhere. Retail is a great place to start because it doesn't have all the regulations. It doesn't have all the safety implications. So it's a great place to start. And so that's what I'm trying to build out now with my team. Ton of fun and kind of mind-boggling when you're trying to think of this scale. You know, it's such an exponential scale. However, some people, fog is a term that people use for that too. You've heard out there. How many retailers do you think care about fog or Internet of Things? There might be one, yeah. How many retailers care about fog or Internet of Things? Yeah, it turns out none of them actually care about Internet of Things or fog. And by the way, as an engineer, this will absolutely confound you for a very long time, even though I've told you this. You'll never remember this lesson and it'll still happen. Yeah. Yeah, so the question was, is it due to the fact that they just don't know?
Yeah, like do they just not know that Internet of Things exists, or do they know and they're purposely ignoring it because it doesn't cut enough of a profit margin for them to care?
It's actually neither. That's not what their business is about. And this is the really super important thing as a technologist that you have to understand. A technology is just a path to solve a problem, one of many. If the village shaman could show up and solve the problem, it's the same to them. As long as it's cheaper, it's better, or more reliable, or whatever. They could absolutely care less. And it's really important for two reasons with the customer. The first one is we assume way too many things, and you can get yourself into a design hole. The second thing is you just put so many constraints on yourself that you've left all sorts of solution possibilities on the table. And so, you know, that's a very critical thing that's there. So if you read this, would you say this is the Internet of Things? Does that look like it to you? Does it look like a Missile Command slide? No, right? What this is This is what they actually want. The first one, and this is market research that we've done, that we've talked about publicly. They want a holistic integration. Right now, they got all these islands of technology that they have to pay for, maintain, try to update, try to integrate, all those things. They want all those islands of technology to go away. That's what they care about. And that's an IT care. I want a 360-degree view into my store. Well, that's a store manager and a merchandiser's care, right? If I can understand what's going on in my store, I can optimize it and I can make a lot more money or sell cooler stuff or whatever the objective is. But what I really want, I don't even care about either of those things so long as I can get real-time actionable insights. And so this is the promise of AI to me, where I can start learning on your data and now I can understand, you know what? Ryan walked in. We know people like Ryan are total cheapskates. We're not going to put the sales associate there. But Dr. Ganesh, that guy is a spender, right? And so we're going to go in and we're going to have the associate there. And you know what? We know he likes pink shirts and we know he likes brown shoes and we know all this thing. So we're going to come up with this great solution just for him. And he's going to feel super special because no one else can do this for me. That's what they want to do in a store. And there's a lot of concepts. Some of them have technology, some of them don't. But that's what they're all trying to do because, yeah.
So kind of like the ads that follow you around, but in real time, in person?
That's actually, so the ads following you around is a different use case, but yeah, exactly.
Okay.
So, but not just that. An ad's kind of interesting. How many people got the ad on something they already bought?
Yeah.
Right? Yes. What a stupid ad. Like, what a waste of money. Yeah. Right? It blows me away people waste their money on those ads. Well, what if you walked in and I knew what you wanted? Or I had a pretty good feeling for it. There's two things, but I only have one of them in my store. Why don't I just advertise the one I actually have in your size and the, you know, I can look at your basic shape and height and everything and do a lot of interesting demographic stuff. And now I can advertise to you just that one that I got because you're going to be a lot happier. If I don't have it, you're going to be mad.
So are you using like all of my social media and stuff to learn that? Like,
Well, so here's the interesting thing. Theoretically, we could. We don't. So for me, it's all about, and this is back to the kind of ethical thing. What data should you be able to acquire about someone? If it's personally identifiable, Intel doesn't want to participate in that. That's just a corporate policy we have. We think personally identifiable information is something that's just not our thing. However, I might be able to say male, this age, this height, the demographic information. Okay. That's probably okay.
okay. Cool.
And so where it gets interesting, and this is not us, but where a retailer might take it is loyalty information. If you've opted in and agreed to do that, like I just heard about a retailer where you take, to sign up to the loyalty program, you take 2 pictures of your face. And once you do that, they'll actually recognize you when you come into the store, and they'll cater the entire experience to you.
Wow.
Which is pretty cool, right?
That is really
Now,
cool.
by the way, someone of my age, they think that's totally freaky. So there's this age gap thing, right, that happens here. They have to be aware of anytime you're building these, and you know, we're having the conversation about sometimes society just does not react well to something. So like in Germany, that would be a big no-no. In China, well, of course, you should do that, right? And so you get these where you have to customize the product based on the local audience.
Awesome.
Okay, so this is what it really looks like. And so if you're the person that lives on the business engineering border, you get this from them and you're like, oh, that looks like fog. How do you get to that looks like fog? 20 years old trying it. I don't know that there's much of a shortcut. AI may figure it out faster than me someday, but so far, my job's safe. Okay, so this is ultimately, last slide here on what it looks like. So what we're trying to build from the responsive retail platform is pretty easy. The other thing I get is, hey, do you use RFID? Do you use cameras, Bluetooth beacons, whatever? I don't care. Retailers, you saw, they don't care. Pixie dust, it's good enough, like whatever. What they really want to know is they want to know something about the customer so I can target for you. I want to know something about the associate. Who's the most productive person? Who's free? Who's trained in a certain task? I want to know about the product. Do I even have it? Which is the first step, which most retailers are not doing well at right now. And if I do have the product, then what are the attributes of that product? Where did it come from? You know, what sizes do I have? Does it run small or large? All these kind of things. And then the store itself. How's it laid out? Is the temperature good? Is the lighting good? It turns out temperature and lighting can impact your sales by 10, 15% just in those variables. And so you think, well, that's kind of silly, but there's a lot of money in 15%, especially in grocery where it's, you know, 3% probably margin, something like that. And so that's what we're trying to sense, and then we're turning it into industry events. You don't care, jeans are still there. Yep, they're still there. Yep, they're still there. No one cares about that. Someone took that pair of jeans and took it to the fitting room. They tried them on, and they did not buy them. But someone else tried those on, took them there, and then went and bought it. That's very useful information that I can now start stitching together and understanding about my entire thing. And so that's what we're trying to do. And then we work with our independent software vendors and the companies, all the software people you think of, to come sit on this, consume that, and offer those great experiences. So that's kind of what I'm building now. It looks really easy on this chart because I had to explain it to the press. It is not easy technically, and we can go as deep as you want on it, but I don't want to bore everyone. Anything else before I get my my final? Yeah.
I'm sure you guys have thought of a bazillion things, and I just think that the associate one is the coolest because I used to work at an AT&T retail store, and we had a lot of people that spoke different languages come in, and if you could know what language that they spoke and that would be like the difference. That's really cool.
Yeah, I agree. That's a great one. And I actually think there's a lot of focus on video right now. I believe audio will be the next sensor that'll have a lot of real promise.
That's very cool, yeah.
Anything else?
The questions. We'll come around with the microphone.
You don't want to see my report card. That's the last step. Okay. So I did not get an electrical engineering degree. I got an industrial engineering degree and worked as an electrical engineer my whole career. So we'll call that good enough, right? I got my MBA from here. Check. I did okay monetarily. You know, for a kid that's growing up in Montana, like way past what I expected to ever do. I did not own a Porsche to this day. Not yet. Well, actually, my goal, I forgot to tell you, I wanted to do these things by the time I was 30. And I totally blew it on the Porsche. Very disappointed about that. My wife even said, do you want to buy a Porsche? It's okay, I'll wait for my midlife crisis. All right, well, thanks so much, everyone. I really appreciate your time.
We wrap up for the day.
What was your best experience at Intel?
My best experience at Intel.
Or what you remember the most?
All right, so I'm going to go personal and then I'll go product. My best experience at Intel was actually the friends I met playing basketball in the rec leagues. Everyone was kind of the same age, and my best friends to this date still came from that group of people that played basketball together and still hang out. We can't play basketball anymore, we're too old, but that was it. Oh, sorry, I got my mic on. From a product standpoint, one of the coolest things, because I was working in the telco space and because the blade form factors are so narrow that you can actually fit compute into, we actually led the transition to performance per watt in servers. And so I actually built, ahead of our competition, the first performance per watt solution at a server class kind of thing. And now that's the entire standard for the entire industry. It's pretty cool.
What made you want to stick with Intel for most of your career the most?
Well, you could say I'm crazy. That's one possibility. But there's kind of one thing I alluded to earlier, and then the second thing I didn't. One was the amount of lives you could touch. It's hard to find a company that touches so many lives. I mean, the whole valley was named after Intel, basically, right? And so it's just an amazing people, and we have an expert in everything, which leads to the second one. And I would recommend, as you look for places, as you go out in your careers, find some place that embraces changing. When I started, you were expected to change jobs every 18 months. If you waited over 2 years, there was something wrong with you. And I love that because I just like to play and experiment and try new things. And I've had 38 jobs at Intel. Sometimes they were like 3 months. They're like, hey, Ryan, there's a problem over there. We go fix it. Okay, you know, like, and then other times it's like, wow, this is really heady. I got to spend a couple years really just developing a strategy, let alone the product and everything else. But they afford me that, and I've been computer architecture, electrical engineering, marketing, pretty much any job you could think of, sales, the whole thing. And I just think it's so cool because I get to reinvent myself every couple of years, and I think that's fun. So that's how I'd answer it. Yeah. Oh, we got to wait for the mic, though.
Okay, I'll shut up after this one. So, have you ever had a project that like you felt like you poured your life into, and it either got a no or it just didn't work the way you wanted it? And how did that you respond to that?
Yeah, so the HEMS project that I talked about was one of them. I mean, we hit a home run. Every house would have one of these now, I truly believe, if we had just done it. My team was so excited and so passionate about it, and it was absolutely heartbreaking. It was almost like having a death in the family from it. It was that emotional for all of us because we really felt like, you know, we're at the point where we can eliminate all sorts of power plants. There was all sorts of just bigger implications that came from this technology, plus it made your life better. And it was crushing. And I'll tell you, if you're old enough, you go home and you have a drink and you pout about it. And then the next day you get up and say, okay, well, we're going to go from here. And for me, I've always been, and I believe this about my people, I made sure every one of them had a job before I started looking for a job. And I still have great people inside and outside the company that have actually one from a very big cloud service provider that went there just brought me a big deal because of our relationship from that. So it could seem pretty dire in the moment, and it hurt. But, man, you know, what came out of that and some of the new ideas and the people and the team that we were able to build, yeah, it was cool. And I think as long as you have the attitude of, yeah, okay, it's the next thing, there's a higher value thing, that didn't work out, you're going to do really well. If you stew on it and you're like, they screwed up and how can they be so dumb and whatever else might go through your head, that's going to be a problem, and that'll just never be an attitude that gets you very far. So, yeah, it was terrible. It really, really, really. I still get together with them and we all get like emotional about it, but it is what it is. You know, it's business. Sometimes it works, sometimes it doesn't.
Right. Well, I appreciate it. Thank you.
Yeah.
What's the one piece of advice you want us to walk away with from tonight?
All right, I'm going to give you a bit of a cheesy answer because a lot of people probably give you that answer, and I'm going to explain it. So dream big is my answer, and I'm sure you've heard that 1,000 times, so like, let me give you my take on it. I think, so growing up, by the time I was 12, I think our mom probably made about $9,000 a year. That was our family income. It never even occurred to me that I could ever do anything bigger or better. And I had people that believed in me and invested in me. Like my friends' parents like took me under their wing and did stuff and helped prop me up and gave me that confidence. If you can have that confidence to do it yourself, to dream big and not care if it fails, you can care what people think of how you're doing it, but don't let it bug you. Just say, you know what, got knocked down, time to get back up. I'm gonna go take another charge at something else. That's it, because I will tell you, there's a lot of smart people out there, right? I compete with internally people from every of the best schools, but I'm willing to go get it and make it happen, and I don't care what it takes to bust through those walls, and it served me very well. So I would say you're never really taught that, quote unquote, but if you could take that lesson out of it, I think you'll do really well. Here's a question here.
So my question was, how did you land your first job at Intel, and how would you recommend for all of us to go about getting a job?
Yeah, I would not recommend doing what I did. We'll just start there. So I was actually married in college, very young. We're no longer together. She was a chemical engineer. She had excellent opportunities in Houston. I had excellent opportunities in the Northwest. And Intel was the place that offered us both a job. Working with your spouse is not a great way to foster a marriage. I would not recommend that. At least for my personality type, maybe it works for you, I don't know, but it just did not work for us. So we actually randomly ended up at Intel just because of that situation. The jobs I've had ever since then, it's really simple. The second I'm not learning anything more, I switch. And I go to something that I think's hard. And I kind of figure first, if it's hard, no one else has figured it, so the bar's pretty low. Like, how could you not do better than nothing, right? So that's a good place to start. And second, I'm going to learn a ton. And I don't know, that constant curiosity is probably the other point to your question that I think is super important. I jump in, try to solve it, fail, come back a couple years later, technology's moved on, oh, I can get it now. And so, probably that mentality is what's worked for me in my career. The first job, probably not the ideal case to do it. All right, well, thanks, everyone. I appreciate it.
Thank you all for coming, and thank you, Ryan. This was a great talk. So 2 things I want to take away from his talk. Engineers learn from failure. You saw that throughout his message, right? And we have to be really resilient to be able to dream big and come up with those innovations. So I hope you will be those kinds of young people doing things that will change the world. And we will read about you when we're really old and can't walk. Thank you. Have a great night. Thank you for coming.
You bet.